Okay, so for this particular chapter, we'll be doing experimental design. So for this, right, you will need to know what are the different kinds of SI units and the physical properties that will be tested and how to go about measuring it. So a common question is, they will actually give you a scenario like how do you measure a fixed volume of 25 cm cube of water or solution. Then you need to be able to give the pipette, because pipette can measure fixed volume. Okay, so when we look at time, the symbol for time is actually seconds as the SI unit, and there are other kinds of common unit like hours, minutes, and days. But the ones in exam we usually take reference with is over here in seconds. How to go about measuring it is either by a digital stopwatch or analog. Analog is your basic mechanical kind of stopwatch, which is no longer used nowadays. So most of it is digitalized. Mass SI unit is in kilograms, and that it usually can be measured either by a beam balance or electronic balance. Some of you may feel that the spring balance can be used, but actually cannot. Spring balance doesn't measure the mass, it measures the weight. So there's a difference between them. Temperature is Kelvin, but over in Singapore we mostly use degrees Celsius. Some common ways to measure this is by the thermometer. Okay, then of course you got the volume. The volume is measured by meter cube, and in this case, right, 1 meter cube, okay, 1000 cm cube equals to 1 liter. So do take note of the measurements difference. You have a few ways to measure now. These are the instrument, right? It depends on what is the accuracy on the measure. So for burette, it tends to be a 0.1 cm cube accuracy or 0.05 cm cube accuracy. Okay. For your pipette, it will be a fixed volume. So this is fixed. So there are like 25.0 cm cube. There is maybe you have 15.0 cm cube. So these are the mixed one. Measuring cylinder, they tend to have in not decimals but mainly in one measurements of 1 cm cube. And gas syringe, generally you use this to measure volumes of a gas. Okay, small volumes of gas. Okay. So when we look at it, measuring volume, this is a gas syringe. It's something like an injection needle, but the word gas in front tells you that it actually collects gas, and it can collect gas of any density, meaning it can collect gas that is of a lower density than air or higher density than air. Okay. Burette is as accurate to 0.1 cm cube, but like I say, you can go down to 0.05 cm cube, but that is subjected to how powerful your eyes are lah. But most of the instruments are to the accuracy of 0.1 cm cube, so you have to measure, you use the burette. It's one of the more accurate kinds of volumes to take measurements from. Then of course you have your pipette that measures the fixed volume of a solution, and in this case there are many different pipettes that are available, but the keyword here is actually the fixed volume, meaning it can only measure one specific volume of the solution. If you want to measure like 15 cm cube or even 20 or even 50, you need to use a different type of pipette. Okay, and then of course measuring cylinder, approximate amount of volume most probably is in measurements of 1 cm cube, and of course for beaker it is even smaller, so it can be in 50s, it can be in hundreds, etc. But beaker are usually used to measure large volumes of solutions. Measuring cylinder at most will measure 100 cm cube, but of course there are even smaller kinds of measuring cylinder, but the one we are looking at is mainly about 100. Okay. Now how to go about reading the measurements? We can read using the under the meniscus. Meniscus is the place where they actually curve, okay, for your liquid. And one rule of thumb is to always read the reading at where it curves. So for water, they tend to curve like this, whereby it's like a happy face. However, for oil and other kinds of like organic kind of solution, they tend to actually curve upwards, and this is where your eyes has to be parallel to the top meniscus, okay, to minimize any form of parallax error. So this is mainly for oil, this one mainly for water, similar things. Okay. Then of course in our experiment we usually collect gas to sort of measure the volume and to measure and to understand how it reacts. Okay, so first of all, gas can be collected through three main ways. Displacement of air, we have upward delivery and downward delivery. Displacement of water, meaning you collect gas using water, and of course gas stream is very straightforward, you just collect the volume. So mainly the gas stream is used to be the only method that allows you to indicate what is the volume of the gas collected. The rest you are just collecting without any form of measurement. So for displacement of air, as I say, there is two main types, downwards and upwards delivery. This indicates the direction in which air actually move towards to. And displacement of air usually use the property of density in comparison to the normal air. So if let's say the gas you collect, you're trying to collect, right, is of a lower density than the air density or density of air, what will happen is the gas would actually float up, right? So gas will float. Gas floats. However, if it's more than the density is more for gas collected as compared to air, it will actually sink. So depending on this, they will have two different methods. Now this one you need to remember. So gas collection, right, for downward delivery is when gas is actually more dense than air. Why? Because in this kind of method, right, the gas will actually sink. So when it sinks, it goes downwards. So let's say I have a particular glass tube and the gas is actually of a lower density. Lower density, it will actually move downwards, and this is why it's called the downward delivery method. Okay. So you could see that the gas actually moves downwards in this manner. And do take note that the test tube has to be in an upright position so that the gas will actually sink downwards. If you put it at a horizontal basis, the gas will not be collected. Next, we look at this, the upward delivery. Upward delivery uses only these two gases, hydrogen and ammonia, where they are less dense, meaning they are lighter than air. So if it's lighter than air, what will happen is the gas will actually move upwards because it floats up, and the gas will be collected here in this region here. Okay, same thing, you invert it, invert position, the gas produced will rise up the test tube so that you can collect it. As you can see, the test tube doesn't indicate any form of measurement, so this is mainly just to collect only, not so much as to measure it. So it's a collection, then you immediately use it for another reaction. Okay, this is another method in which you can collect the gas if it's less dense than air. Displacement of water is usually suitable to collect any form of gas depending on whether is it soluble in water. Okay. Now what happens is, if it's soluble in water, you will not be able to use it to collect this method to collect the gas, because the gas will dissolve in water. And when the gas dissolves in water, it will not appear in the volume, and therefore you cannot collect it. So what you do is you actually pass the volume of gas past the water, and subsequently the gas will actually float upwards. Okay. Of course, this is one of the more accurate way of measuring of collecting gas. So how you would prioritize is, first you consider whether the gas can be collected through displacement of water. This is your first one. Second, you go by air delivery. That means whether upwards or downwards. So the first property is, you must ask yourself, is gas soluble in water? If it's not, you use displacement of water method to collect the gas. Okay. if it is soluble, then the next question you should ask yourself is gas denser or less dense than air? If it's denser than air, then you use upward delivery to collect the gas. If it's less dense than air, you do downward delivery. So these are the ways to go about collecting the gas. Okay. Now, drying agents can be used to obtain a dry sample of gas by removing its moisture content. So the three common drying agents used in the lab to dry the gas is usually anhydrous means dry, calcium chloride, or sulfuric acid, or calcium oxide. Do take note that different kinds of chemicals can be used for different drying agents. Okay, because some of these can even react with the gas itself. So do take note of all these examples that you can use this component. So this usually comes out in the MCQ. Another thing to take note is if you are required to measure the volume of gas produced, then you would want to, if volume of gas needed, then you would want to do the gas range. Okay, to collect the gas. And of course, being a gas stream, you don't really have to think so much as whether it's soluble in water or density. You just can collect it quite naturally. Okay, so next is how to go about identifying the gas. So the test of gas is very important. Definitely in exam they will ask you one out of the three. There is actually 4 main gases which you need to know. Actually 5, you could think of 5. So first of all, carbon dioxide, you pass lime water into it, there will be effervescence and white precipitate be formed if carbon dioxide is present. If carbon dioxide is absent, the solution will just remain clear, or no white precipitate is formed. For hydrogen gas, you would need to use a burning spleen. A burning spleen is basically a lighted stick where the top part is actually red in color. No, that's glowing. So for burning spleen, is basically a stick that has a flame at the top. Okay, because burning means got fire, so there must be got fire, got flame or got fire. And what happens is this burning spleen, when you expose it to hydrogen gas, it extinguishes. That means it gets put off with a pop sound. So you'll be able to hear the pop sound very distinctively if hydrogen gas is present. Do remember this phrase. These are the ones that they are really looking for in exams. In terms of explanation. Okay. Next, glowing spleen is just basically this burning spleen. And then for glowing spleen, is mainly whereby the stick has this red color glow or orange glow. Okay, and it's hot, like the cigarette butt when there's a flame there, and there's this like red color fire kind of thing, ember. So that is the difference between the word glowing and burning. And when you expose this to oxygen, it will reignite to form that fire or that flame again. Ammonia is generally NH3, and what you can do is you can actually use a litmus paper. Now the litmus paper, the change in color, right? The change in color actually is quite straightforward. Now because ammonia is a kind of special gas, So in a sense, ammonia gas is actually alkaline in nature, and by using a moist red litmus paper, the red litmus paper, the moist red litmus paper will turn blue because ammonia is actually a alkaline gas. This one we'll learn more in the next few chapters. So that it has to be moist because it wants to detect the gas easily, absorb the gas easily. Then for chlorine gas, Cl2, you tend to use any form of moist litmus paper, any one of it will do, any color, either red or blue, and it will actually be bleached. Okay, bleaches the litmus. Bleaches means it tends to decolorize, or it turns white, because chlorine is a natural bleacher. So usually these are the four main ones that are tested. Chlorine is just there as an additional example, but you need to know the phrasing, you need to know how to do the test, what reagent you use, and that's all for this identification of gas. Okay, so I have already explained all this in terms of what are the tests for gas, how to go about collecting gas. There are altogether a few main methods to collect gas: displacement of water, upward delivery, downward delivery, and of course using a gas stream to measure volume of the gas. How to go about drying the gas, and then of course what you also have learned is what are the different instruments that you can use to collect volumes of not just gas but liquid, or to measure times and things like this. Okay, so that is